Hi everyone, my name is Pankaj. Today we're going to discuss TCP or IP reference model in computer networks and TCP or IP model. And TCP or IP was designed and developed by the Department of Defense body in the 1960s and is based on the standard protocols. It stands for Transmission Control Protocol or Internet Protocol. The TCP or IP model is a concise version of the OSI model. It contains four layers, unlike the seven layers in the previous model. When we can invoice a model, there are seven layers, and when it comes to a TCP/IP model, there are four layers, and the number of layers is sometimes referred to as five or four. So uh, we can consider the number of layers in voice TCP/IP model. Sometimes more four or maybe sometimes five. So the physical layer and data link layer are referred to as one single layer, as the physical layer or interface layer in the core layer interface. And so here the physical layer and data layer refer to a single layer, and the physical layer network layer interface. Okay, are the next one? What does TCP or IP do? The main work for TCP or IP is to transfer the data of a computer from one device to another. So it plays a vital role in transferring the data from one computer to another computer. And the main condition of this process is to make the data reliable, and accurate, so that the receiver will receive the same information sent by the sender. And um, data reliable, and whatever the sender sends the information, the same will be received by the receiver from another computer. So to ensure that each message reaches its final destination accurately, the TCP or IP defines its data into packets or combines them at the other end, which helps in maintaining the accuracy of the data while transferring from one end to other end. And next one, and that what is the difference between the TCP and IP? TCP and IP are two different protocols of computer networks. The basic difference between the transmission control protocol and internet protocol is in the transmission of data. So we know that TCP or IP are the two different protocols, and they may work, but transferring the data uh, from one computer to another computer for sir, or maybe source to destination. But the transmission process will be different. Transmission of data. In simple words, IP finds the destination of the mail, and TCP has the work to send and receive the mail. UDP is another protocol which does not require IP to communicate with another computer. IP is required by only TCP. This is the basic difference between the TCP and IP. And how does the TCP or IP model work? Whenever we want to send something over the internet using the TCP or IP model, the TCP or IP model divides the data into packets the sender sent. And the same packets have to be recombined at the receivers and to form the same data. And this thing happens to maintain the accuracy of the data. TCP or IP model divides the data into a four layer procedure where the data first go into this layer in one order, and again in reverse order to get organized in the same way at the receiver's end. And uh, uh, the layers of TCP and IP models are: first one, application layer, and the second one, transport layer, TCP or UDP, and third one, network or internet layer, IP, and fourth one, data link layer, which serves as a MAC, media access control, and fifth one, physical layer. The diagrammatic comparison of the TCP or IP and voice model is as follows. And yeah, as you can see, OSI diagrammatic and TCP/IP diagrammatic. In OSI, there consists of some layers such as application layer and application layer, representation layer, session layer, transport layer, network layer, data link layer, and physical layer. When it comes to TCP/IP, and TCP/IP, it mainly consists of application layer, transport layer, network layer, network access layer. In yeah, TCP/IP, in TCP/IP, application layer consists of both application layer, present combination of application layer, presentation layer, and session layer. And transport layer is separate, network layer is separate. But when I say the data link layer and physical layer are two separate layers, but it comes to TCP/IP, the combination of a data link layer and physical layer is known as a network access layer. And first one, physical layer. It is a group of applications requiring network communications. This layer is responsible for generating the data and requesting connections. It acts on behalf of the sender and network access layer on the behalf of the receiver. During software, we'll be talking on the behalf of the receiver. And data link layer, the packets and protocol type. In this case, TCP or IP is identified by the data link layer. Error prevention and framing are also provided by the data link layer. And point-to-point protocol, PP, triple P framing, and Ethernet, IEEE 802.2 framing are two examples of data link layer protocols. And third one, internet layer. This layer parallels the functions of OSS network layer, defines the protocols which are responsible for the logical transmission of data over the entire network. The main protocols residing at this layer are as follows. First, IP. IP stands for Internet Protocol, and it is responsible for delivering packets from the source host to the destination host by looking at the IP addresses in the packet at headers. IP has two versions, IPv4 and IPv6. IPv4 is the one that most websites are using currently, but IPv6 is growing is as the number of IPv4 addresses is limited in number when compared to the number of users. And the second protocol is ICMP. ICMP stands for Internet Control Message Protocol. It is encapsulated within IP datagrams and is responsible for providing hosts with information about network problems. And the second protocol and third one protocol is ARP. ARP stands for Address Resolution Protocol. Its job is to find the hardware address of a host from a known IP address. ARP has several types: reverse ARP, proxy ARP, gratuitous ARP, and inverse ARP. And the fourth one is a transport layer. The TCP/IP transport layer protocols exchange data, receipt acknowledgements, and retransmit missing packets to ensure that packets arrive in order and without error. End-to-end communication is referred to as such. Transmission control protocol and user datagram protocol are transport layer protocols at this level, UDP. And the main two protocols are TCP. Applications can interact with one another using TCP as though they were physically connected by a circuit. TCP transmissions data in a way that resembles character by character transmission rather than a separate packets. A starting point that establishes the connection, the whole transmission in byte order, and an ending point that encloses the connection make up this transmission. And the second one is a UDP. The datagram UDP is a user datagram protocol, and the datagram delivery service is provided by UDP, the other transport layer protocol. Connections between receiving and sending hosts are not verified by UDP. Applications that transport little amounts of data use UDP rather than TCP because it eliminates the process of establishing and validating connections. And the fifth one is application layer. This layer is analogous to the transport layer of the OSI model. It is responsible for end-to-end communication and error-free delivery of data. It shields the upper layer application from the complexities of data. The three main protocols present in this layer are HTTP and HTTPS. HTTP stands for Hypertext Transfer Protocol. It is used by the World Wide Web to manage communications between web browsers and servers. HTTPS stands for HTTP Secure. It is a combination of HTTP SSL Secure Socket Layer. It is efficient in cases where the browser needs to fill out forms, sign in, authenticate, and carry out bank transactions. And the second one is SSH, stands for Secure Shell. It is a terminal emulations to software similar to Telnet. The reason SSH is preferred is because of its ability to maintain the encrypted connections. It sets up a secure session over a TCP or IP connection. NTP, it stands for Network Time Protocol. It is used to synchronize the clocks and our computer to one standard time source. It is very useful in situations like bank transactions. Assume the following situation without the presence of NTP. So this is the about a TCP or IP reference model, and it consists of mainly five layers. Those are physical application layer, transport layer, TCP/IP network layer, internet layer, data link layer, and physical layer. And thank you guys.